Okay guys, the lesson today is to be able to find the number of combinations. Okay, what do we mean by a combination? A combination is simply a group of items in which the order of the items is not considered. Okay, well what do we mean by that? Well, let's take a look. Okay, you have a table below. It contains 4 yogurt toppings: raisins, nuts, blueberries, and granola. How many different ways can you choose 2 toppings? Now, in our previous lessons, when we talked about permutations, right, if you have 4 different if you had 4 different items, and we're looking for the number of different arrangements of the 4 different items, that's what we would mean by permutations. Here we're talking about combinations. So let's take a look. If we first made an organized list of all the possible combinations of toppings, right? We are taking 2 at a time, right? Use the letter to represent 4 possible combinations of toppings, and we're choosing 2 toppings at a time here, and only 2 toppings. So if we made an organized list, right, there'd be 4, there'd be 8, there'd be 12 different possible permutations of toppings. If we crossed out the duplicates, meaning raisins and nuts would be the same as nuts and raisins. So raisins and nuts, nuts and raisins, right, they're the same 2 toppings. So we cross them out, right? If we had blueberries and raisins, blueberries and raisins would be the same as raisins and blueberries. So we cross that out. We have blueberries and nuts. Blueberries and nuts would be the same as nuts and blueberries. So we cross it out, right? We cross out. Granola and raisins would be the same as raisins and granola, right? Granolas and nuts would be the same as nuts and granola. So we cross it out, right? What is that? Granola and blueberries would be the same as blueberries and granola. So we're left with 1, 2, 3, 4, 5, 6 different combinations of 2 toppings. Okay, 6 different ways to choose 2 toppings, 6 different combinations, right? There'd be 12 permutations of the 4 items, taken 2 at a time, but only 6 combinations. And we use combination notation to kind of represent that situation. Okay, how does this work? Well, combination notation, similar to permutation notation, except that to find the number of combinations, we take the number of permutations and we divide by the number chosen at a time, or the number of objects chosen at a time. It's factorial. Okay, so for example, 7c3 is the same as 7p3 divided by 3 factorial. So that would be 7 times 6 times 5 divided by 3 times 2 times 1. By dividing by, well, let's go back and take a look, and we'll show that here. Okay, probably should have done that. That would have been the better thing to do. So if we take a look at 4p2, right, that's going to be the same as 4 times 3, which we know is 12, right? And that's what we have right over here, right? The number of permutations. Combinations would work like this. 4c2 would be to take the number of permutations 2 at a time, 4p2, and divide by 2 factorial. So that's going to be 4 times 3 divided by 2 times 1. 4 times 3 is 12. 2 times 1 is 2. 12 divided by 2. That gives us the 1, 2, 3, 4, 5, 6 different combinations. So, but by dividing by the factorial of the number of items taken at a particular time, you are eliminating the duplicates of an item. That's why we're dividing by that 2 factorial. We're eliminating the duplicates of the item. All right? And that's what we see here. We find the number of permutations, and then we divide by 3 factorial to eliminate the duplicates, and that's where we would get 35. All right? So remember, combinations is when the order of the objects does not matter, right? And that's how you distinguish between the permutation in which the order does matter, like first, second, third place, or a combination where the order doesn't matter, like if we're talking about pizza toppings, because pepperonis and extra cheese is the same as extra cheese and pepperoni. Okay, so let's continue with some examples. All right, Paul owns 6 dress shirts. He plans to wear 3 of them at work this week. How many different combinations of 3 shirts can he wear? All right. Well, let's take a look and see, what that's going to look like. If we're using our combination notation, we have 6 dress shirts, right, and we're taking them 3 at a time. So that's going to be 6C3. How are we going to find the number of combinations? Well, we start with the number of permutations, which would be 6P3, and we divide by the number of items taken at a time, its factorial, 3 factorial. So that's going to be equal to the first 3 factors of 6 factorial, so that's 6 times 5 times 4 divided by 3 factorial, that's 3 times 2 times 1. So what do we get there? 6 times 5 is 30. 30 times 4 is 120. We divide that by 3 times 2 times 1. That's going to be 6. 120 divided by 6. There'd be 20 different combinations for that situation. All right? So combinations is different from the permutations, and we want to be able to eliminate, right? By dividing by that factorial, we are eliminating the duplicates. Okay. Let's try the next one. Sam has 4 pencils. He needs to use 2 of them. How many different combinations of 2 pencils can he use, right? And if you're thinking about that, right, pencils, the order is not going to matter because the pencils are the same. So let's take a look. That's going to be 4. What is that? C2. So that's going to be 4P2 over 2 factorial. Right? We have 4 items taken 2 at a time. How many different combinations can we make? 4P2 is going to be the first 2 factors of 4 factorial. So that's going to be 4 times 3 divided by 2 factorial. 2 times 1. It's going to give us 12 divided by 2. 12 divided by 2. We wind up with 6. 6 different combinations for that situation. All right? Let's try our next one. A deluxe pizza has 3 toppings. You can choose any 3 of 7 different toppings for your pizza. How many different deluxe pizzas are possible? And once again, understand it's a combination because the order does not matter. The order of the items doesn't matter. Pepperoni, mushrooms, and extra cheese is the same as extra cheese, pepperoni, and mushroom. Right? They're the same. Or it would be the same. The order does not matter. So we're talking about 7 items taken 3 at a time. 7 different toppings, any 3 at a time. So that's going to be 7P3 over 3 factorial. 7P3 is the first 3 factors of 7 factorial. So that's 7 times 6 times 5 divided by 3 factorial. So that's 3 times 2 times 1. What's that give us? 7 times 6 is 42. 42 times 5. That's 210. Divided by 6, 210 divided by 6, that's going to give us 35 different combinations of 7 different toppings that you can take 3 at a time. All right? Do a few more. April has 4 chores to do, and she can do them in any order. How many different sequences of chores can she pick from? All right? So once again, right, we're told that the order does not matter. She can do them in any order. But the question asks, well, how many different sequences of chores can she pick from? Well, 4 different chores, and she can do them in any order. How many different sequences of chores can she choose from? Well, that's simply going to be 4 factorial, right? So that's going to be 4 times 3 times 2 times 1. So there are 24 different sequences of chores that she can pick from. Okay? Let's see. 4 letters, A, B, C, and D, taken 2 at a time. Okay? Well, that would be 4C2, and that's going to be 4P3, 2 over 2 factorial. So that's going to be 4 times 3 divided by 2 times 1. And that's going to be 12 divided by 2. There'd be 6 different combinations there. All right? Next example. There are 9 candidates. There are 9 candidates running for seats on the town council. 3 posts are available: president, vice president, and treasurer. To find the total number of possible arrangements, do you need to find combinations or permutations? Right? Explain, and then find the number of different arrangements possible. Well, one of the key words there is arrangements. And arrangements is one of those key words that let you know you're looking for a permutation. But the other thing you should understand is that, right, the president, the vice president, and the treasurer, the order does matter, because vice president is different from being president. So we're talking about a permutation. So if we have 9 candidates and we're taking them 3 at a time, it's going to be the first 3 factors of 3 factorial. So it's going to be 9 times 8 times 7, and that's going to be 504 possible arrangements there. All right? Let's try another one. How many different pizzas can be made using 0, 1, 2, 3, or 4 of the following toppings? All right? We're talking what? Pepperoni, onion, mushroom, and green pepper. All right? Well, let's talk about 0 topping. So that would be 4 taken 0 at a time. Well, what's 4C0? Well, 4C0, 4 objects taken none at a time. There's only one possible way to do that. All right? Well, 4C1, that's going to be the same as 4P1 divided by 4, what would that be? 4P1 divided by 1 factorial, and that would wind up being 4, right? Because that's 4P1 divided by 1 factorial, so that would be 4 divided by 1, which is 4. Then we have 4C2, right? If we're taking them 2 at a time, 4C2 is going to be equal to 6. Then we have 4C3. 4C3 is going to be equal to 4. And then we have 4C4, which is equal to 1. So if we add all of that up, that's 10, 14, right? There'd be 16 different combinations for that situation. Right? 16 different combinations there. All right? Let's look at this next one. An ice cream shop offers 5 different flavors of ice cream. If you're buying a 2-scoop cone, how many different combinations for a double scoop cone can you choose from? Right? Unless you want the order of your ice cream to be in a specific order, right? We'd be talking about combinations there. So that would be 5C2, which is going to be 5P2 divided by 2 factorial, which is going to be 5 times 4 divided by 2 times 1, and 20 divided by 2. You're going to have 10 combinations for that situation. All right? All right, let's see what we got here. How many groups of 2 can be formed from a committee of 6 members? Now, we're just talking about groups of 2, so groups of 2, and we're going to be combinations. So that's going to be 6C2, which is equal to 6P2 over 2 factorial, which is going to be equal to 6 times 5 divided by 2 times 1, which is going to be 15 combinations for problem 1. Problem 2, find the number of ways you can choose 3 lures from a box using 8 fishing lures. Right, and right there, right, or is the order going to matter with fishing lures? No. So we're talking about combinations there. So that's going to be 8C3, 8 lures taken 3 at a time. That's going to be 8P3 over 3 factorial, which is going to be 8 times 7 times 6 over 3 times 2 times 1, right, which gives you 336 over 6, which is going to give you 56 different combinations for fishing lures there. All right? Okay. last page here for our combinations, and then you guys will get some practice on your own. A record club offers a choice of 9 records from a list of 60. In how many ways can a member make a selection? Well, if we're talking about records from a list of 60, the order of the records certainly isn't going to matter. So that's going to be a combination because the order of the records selected does not matter. Let's look at number 2. All right, we're trying to determine whether we're looking at a permutation or a combination. 100 people purchase lottery tickets. 3 winning prizes will be selected at random. First prize is $100, second prize is $50, and the third prize is $10. How many different ways can the prizes be awarded? Obviously, the order of the winners matters there because the first prize is much more than the second or third prize, right? So that we're talking about permutations, and that's a permutation because the order of the selected winning tickets does matter. All right, let's try example 3. How many different 4-letter user IDs can be formed from the letters D, A, and Y if no repetition of letters is allowed? Well, is the order of the letters going to matter if we're talking about a letter ID? All right, if we're talking about is D, A, and Y going to be different than Y and AD? And the answer is yes, right? So it is a permutation, right? Because the order of the selected letters does not matter. And question 4, 7 of the sample of 150 computers will be selected and tested. How many ways are there to make that selection? Well, if you're talking about computers, right, and selecting them and testing them, the order is not going to matter. So that's going to be a combination because the order of the computers selected does not matter. All right. Okay, guys, right? That's going to be our lesson for permutations, or I'm sorry, for combinations. Right? You can kind of see how the permutations and the combinations are connected and related. Combinations, the order of the items does not matter. Right? Permutations, the order is important. So as long as you keep those two ideas separate, you guys should be fine. All right, I hope that's helpful and enjoy doing the problems next couple days. Take care.